This is Food Science 571, Food Process Engineering Technology. This is your instructor, Dr. Barrett Vaughn of the Food and Nutritional Sciences Department. We are beginning Topic 2, Physical Properties, and this is Lecture 1 of 4. We start this section with a quote from Lord Kelvin. When you can measure what you are speaking about and can express it in numbers, you know something about it. And when you cannot measure it, when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. It may be the beginning of knowledge, but you have scarcely in your thoughts advanced to the stage of science. In this chapter, we are discussing the physical properties of food materials. Physical characteristics influence how biological materials are handled, processed, consumed, and stored. This can be seen with a simple example showing how milk, which is usually sold in types of waterproof containers, is handled or consumed and stored differently than bags of flour. Food materials are biological. By and large, they are irregular in shape. They have a non-normal frequency distribution in terms of their likeliness to each other. They have a heterogeneous composition, that is to say, most biological materials are not all the same thing all the way through it. For example, an orange has rind, has the juice, has the pulp, and also has seeds. It's not all one thing. There's also variety, which can be different for a different biological material. You have growing conditions have an influence, the maturity of it has an influence, and all of these different things influence the properties of a biological material. They're affected by chemical changes such as decomposition, moisture, respiration, and enzymatic activity. The values of characteristics vary widely. For example, particles of powdered milk have diameters from 10 all the way to 150 micrometers. And watermelons have diameters as high as half of a meter, or 1.5 feet. Physical characteristics are important to engineers, processors, food scientists, plant and animal breeders, and other scientists. The response of food materials to physical treatments has a lot to do with food safety and quality. Defining and quantifying a description of the food material is important. Providing basic data for food engineering and unit operations, depending on what kind of process we want to take the food through, and also predicting the behavior of a new food material. Physical properties are the characteristics of a material which are independent of the observer, measurable, can be quantified, and define the state of the material, but not how it attained that state. Physical characteristics, mechanical properties, thermal properties, electrical properties, and optical properties are all the different ways that we look at different materials. There are several different classifications of physical properties that we'll deal with in this course. The first are physical characteristics. Those are things such as shape, size, weight, volume, surface area, density, porosity, color, appearance, drag coefficient, and center of gravity. Also, there are mechanical properties that are of interest. Those are things such as hardness, compressive strength, tensile strength, impact resistance, shear resistance, static coefficient of friction, sliding coefficient of friction, compressibility, coefficient of expansion, elasticity, plasticity, bending strength, aerodynamic properties, and hydrodynamic properties. Those are properties that have to be measured. Another classification are thermal properties. For example, specific heat, thermal capacity, thermal diffusivity. Those are thermal properties. Also, electrical properties such as conductance, resistance, capacitance, dielectric properties, reaction to electromagnetic radiation, conductivity, that is charge holding ability, Also, their optical properties: light transmittance, light reflectance, color, light absorbance, contrast, and intensity. So there are a variety of different properties that are physical properties that we examine. In terms of physical characteristics, we examine a number of different things, such as size, shape, particle density, bulk density, porosity, and surface area. But when we talk about size, you have to be clear about what it is that you're actually going to measure. When you're dealing with things like peas and cantaloupes that are spherical, you're measuring the diameter. When you're dealing foods like a kernel of grain or a potato that's classified as ellipsoidal, you look at the longest or shortest diameter and the intermediate diameter. When you deal with things like pears and carrot that you could call pear-shaped, you look at the diameter of the largest part and the overall length in the stem direction. You also have a number of irregular shaped objects where it's very complex in terms of measuring the shape. Normally you use at least 100 more grains or specimens for size determination so that you're sure that you get a balanced sample. And the size is affected by the location and the variety. So you may be asking the question, what is the importance of size? Well, size goes into your surface area calculation, which has an impact on heat transfer and also if you're coating the surface. Also, you consider the separation of foreign materials, which goes into grading, and you have energy requirements during grinding, which is important in terms of size. Also, you have size measurement. You can use a device called vernier calipers to measure size. You can also use a machine vision system as well. Another physical characteristic, shape, is also very important. It's used mostly for grading. Examples of different shapes are round, oblate, oblong, conic, ovate, lopsided, oblate, elliptical, truncate, unequal, ribbed, regular, irregular. And the roundness or the sphericity is used to quantify differences in the shape of food or other agricultural materials. Here you see the equation for the sphericity, which is the volume of an ellipsoid with equivalent diameters over the volume of a circumscribed sphere to the 1/3 power. So, for example, if the average major, intermediate, and minor diameters of barley is as listed, you can calculate the sphericity. You can also calculate the sphericity of a soybean, and that there is given. Another characteristic that's important is volume, and this can be important when you're determining storage space. In terms of measuring volume, there's one particular piece of equipment that you can use, especially if you're dealing with things like grains of rice or different grains, and it's a pycnometer or graduate burette, and this diagram gives a little explanation of how those are used. Here we have the equation for using the equipment, and we're trying to find the volume of the solid itself. So we use the weight of the equipment, the weight of it filled with fluid, the weight of it containing the solid without fluid, and then the weight of the equipment containing both the solid and the fluid. And it's important that we also know what the fluid density is. And so when we find out the average volume of the particle is that volume divided by the number of the particles that we actually placed in the equipment. So you have the burette method where the volume of particles added should be at least 10 times the smallest gradation on the burette. And the different fluids that you can use for this particular technique are alcohol, toluene, tetrachloroethylene, and they all have low surface tension and are slowly absorbed by the solid because you don't want the solid to soak up your fluid, and these are things that won't occur by and large. There are other ways of measuring volume. You also have an air compression pycnometer, and that you get the volume of particulate solids and irregularly shaped materials that you can't really use fluid with. Also, when you're dealing with larger objects, you can also use a platform scale and a beaker, and if it's not going to be soaked in by it, you can use water as the fluid. Another important physical characteristic is surface area. In terms of measurement, you can peel it in narrow strips or coat it and then peel the coating material. In terms of coating, you can use silicone rubber for large objects or metal powder for grains. You can also use the similarity to geometric solids. For example, for a grapefruit, you can use the surface area for an oblate spheroid. For a wheat kernel, you can use a triaxial ellipsoid. For a potato, you can use two segments of a sphere with ends joined by a series of truncated cones. And those can be ways to use estimates to actually find out what the surface area of a biological material is. In terms of importance, the surface area is important when you're calculating the amount of wax applied to fruit, when you're considering the packaging film needed to wrap fruit, and also for heat and mass transfer calculations, which are proportionate to the surface area. For leaves, you use contact printing surface on a light-sensitive meter and measuring the area with a planimeter or doing image processing. And the surface area is also a function of the weight, and that can be a way that you find it. This concludes the first lecture of 4 for the Topic 2 Physical Properties. If you have any questions, please contact me at the email address listed in the syllabus. Thank you.